We've been reviewing linear functions the last couple of days, even though they were a review for when we did lines in the first place, so that we could talk about nonlinear functions today. So nonlinear functions are graphs or functions that are not lines. Okay, so linear means a line, nonlinear means not a line. So a linear function is a constant rate of change, which means the pattern is consistent every single time, the slope is always the same. But a nonlinear function does not have that constant rate of change, which makes its graph end up curved instead of a line. So when we are trying to see if tables are linear or nonlinear, really we want to look at the pattern. So I mentioned this earlier in the week, but you want to make sure the pattern's the same every single time if it's linear. So here I'm adding 4. It looks like I'm still adding 4, so that's good. Here I'm adding 2. And we do add 2 the whole time. So since it's the same every time, this is a linear function. Okay? For this one, I am subtracting 5. It looks like I'm continuing to do that here and here, so that's good. Here I'm adding 3, but then I'm adding 4 and then 5. So since it's not 3 every single time, this is nonlinear. Okay, it is still a function though, because none of our x's repeat. Okay, when deciding if an equation is linear or nonlinear, linear, remember, is when you have anything that is y equals mx plus b, where you have a slope and an intercept, anything that can be written that way. So if we take a look at some of these, this one, to get rid of my parentheses, I'm going to go ahead and distribute. And then we have y equals 4x minus 4. So that is a line, it's in the correct form. Here we have y equals 4 divided by x, like that. This cannot be written in this way, okay? 4 divided by x is not the same. It is not the same as having a number in front. Not the same as a fraction in front, okay? 4 divided by x is the same as if I had an exponent of -1, which we'll talk about later this year. And since it has an exponent, it is not a linear function. Okay, so this is nonlinear. And then same here. I have an exponent. This cannot be written in this way. It is nonlinear. Okay, so no exponents allowed. When looking at a graph, it's usually pretty apparent. So this is definitely not a straight line, it's curved, so it is nonlinear. I don't have anything for you to cut and paste today, but I do want you to sketch this picture. It doesn't have to be perfect, just sketch the curve. And then here, a horizontal line is linear. All right, today your assignment is actually out of the book. So this is posted on Classroom. You're doing, the whole page is posted, but we're working on 1, 2, and then 7 through 13. Okay, so it's on the same post as this video.